Good afternoon, everybody. My name is John MacArthur. I'm a committee member of LCANZ. I'm going to introduce Chanjeev and then leave Chanjeev to make his presentation. But first, Chanjeev is a postdoctoral researcher at the School of Agriculture and Environment at Massey University. Research focuses on the development and implementation of absolute sustainability assessment methods. His previous research work as a research officer at Massey, where he was investigating the development of science-based target approach for buildings, applied the approach to residential and commercial office buildings in New Zealand. Prior to that, he was a research affiliate at the University of Sydney, visiting researcher at the Technical University of Denmark, and a lecturer at the University of Jaffna in Sri Lanka. Chanjeev is a graduate of the University of Peradeniya in Sri Lanka with a first class in production engineering. Welcome, Chanjeev.
Thank you for giving the opportunity to speak at the first webinar in the LCANZ series. So today I'll be talking about the science-based approach which we developed to calculate climate targets for the buildings in New Zealand. So the project was mainly funded by the Building Research Association of New Zealand and was supervised by Professor Sarah McLaren and David Dowdell from Brands, as well as Roman Jacks is also from Brands. So I'll be giving a brief introduction of the approach, and if you have any questions, please feel free to ask once I'm done with my presentation. I'll start with the question: what does LCA mean to buildings? So I hope everyone has an idea about what LCA. So in terms of LCA for buildings, they generally evaluate the environmental impacts of a particular product. If it's a building, it may be a material, it can be a component, a steel bar or cement, etc., etc. And then it will tell how better in terms of another product. For example, steel bar A better than steel bar B, or the other way. So these outcomes generally help us to compare the environmental impacts and then come to a kind of environmental improvements in terms of relative assessments. But the question is, do these relative assessments like LCA and their results are always sufficient to achieve environmental sustainability? Yes, no, or maybe. So there are different answers. So in one way, yes, they may help because they are supporting eco-efficiency improvements. But when the production volumes increase and the demand increases, the question whether the eco-efficiency improvements is sufficient to achieve sustainability. So in that case, it is obvious only improving the eco-efficiency of products or materials is not sufficient to achieve environmental sustainability globally. So what should be the solution? The solution can be setting some benchmarks, but they cannot be just relative, they should be absolute. That means these benchmarks should inform the environmental impacts in terms of the global environmental boundaries. For example, in the same case, these buildings are now relatively evaluated, but if there is a target or a benchmark in terms of the global environmental boundaries, then we can decide whether the building or the building materials which we use are really sustainable and whether they can be considered sufficient to achieve global environmental sustainability. In that context, there is quite a big interest in terms of developing science-based targets. So you may have heard these science-based targets are trying to align the environmental impacts of companies, sectors, countries, cities with regard to the global environmental targets. So these approaches are available for products like generally electricity, steel, which sectors are kind of unique. So for example, a steel produced in New Zealand and a steel produced in China can be directly compared. But when it comes to the construction sector, such direct comparisons is not possible because the context of the construction, the material requirements, and the environment, and the temperature, weather, so many factors are influencing the construction sector, and as well as the complexity of the buildings and the materials which we use also have some implications on defining such an approach. Furthermore, compared to a particular product like a computer or car or any other product which has a shorter lifetime, buildings have quite a longer lifetime. For example, in New Zealand, residential buildings have a lifetime up to 150 years. There are some buildings which are older than 150 years. So in this context, we have to address these different challenges when setting climate targets or environmental targets for the construction sector. To that end, there are some efforts to date which have focused on setting climate targets for different buildings, particularly in Switzerland and Denmark. So what they have done is they have tried to calculate the share of the global carbon budget available in the future for a particular building, like what is the amount of climate impacts a residential house in Switzerland can emit in 2050. But the problem with these existing approaches, those targets are proposed only at a building level. So they don't inform the targets at the life cycle stage, because when we have to improve the life cycle of the building, as LC analyst, we should know what are the climate targets or what are the environmental targets we have at different life cycle stages, because those targets will help us to come up with solutions to improve the environmental sustainability of the building over the lifetime, but at different life cycle stages. And the other thing, the existing approaches when setting environmental targets, including climate targets, they don't consider how the current building patterns, like the floor area, it can be gross floor area or net floor area, how the trend varies, and what are the trends in the number of buildings that would exist in the future. So those existing approaches fail to evaluate those key aspects which will have severe impacts on the sustainability of a residential sector or the commercial building sector of a particular country. So to that end, we have come up with an approach. It may look a bit complicated, but I'm going to explain step by step so that you can get an idea how to set a climate target. So in this webinar, I'll be talking about setting a climate target for a residential building in New Zealand, particularly detached house. So what we first do is we calculate the climate impacts of a pre-existing detached house, that means which has already been built, and we also model a set of new detached houses that could exist in the future, that will be built in the next few years. And also we have the New Zealand statistics consensus, which based on that we project what will be the building stock from 2018 up to 2050. So when we know what are the amount of existing buildings and the future buildings, we can calculate the climate impacts of the New Zealand building sector. Likewise, on the other hand, we take the global carbon budget for the 2 degrees Celsius climate threshold and assign a share of the global carbon budget, firstly to New Zealand, based on the population. So what is the share of population between 2018 and 2050 in New Zealand compared to the global population? So we get the carbon budget available for New Zealand. And then, based on the New Zealand's climate impacts of the building sector to the New Zealand's total consumption-based climate impact, using that ratio, we assign a carbon budget share of this New Zealand carbon budget share for the construction sector to the New Zealand's carbon budget to the construction sector. Then we come to the carbon budget share which is available for the detached houses. So we're going to share the carbon budget of detached houses between pre-existing, that is the old buildings which have already been built, and then we're going to assign a share of that old building detached house sector to the life cycle stages. So we have the carbon budget which is available for the old buildings, and we know what are the life cycle stages that would be involved with these old buildings. So for example, if you take an old building in the period of 2018 and 2050, we don't have to consider about the construction of the building, or we don't have to consider about the production of materials which are used during the construction. So the main priority will be the operational phase of the buildings, and some buildings will be demolished during this period. So those are the key life cycle stages we have to focus for pre-existing buildings. So we'll set climate targets based on those life cycle stages. And then when you have climate targets for different life cycle stages, when you get the information about the flow area of the building, then you can upscale those climate targets based on the flow area, so that you have a climate target for the entire whole building, entire pre-detached building. Likewise, we can do it for the new build detached houses, check the carbon budget for the new build detached housing sector, and consider what are the life cycle stages. So in this case, if you see a new build detached house has a lifetime of 90 years, they don't have to think about the demolition phase, because it won't happen during this 32-year period. But the main focus should be about the construction of the building and the maintenance, as well as the operational use energy phase of these buildings. And then we again share this carbon budget to different life cycle stages. Finally, we upscale the life cycle stage climate targets to calculate a climate target for the entire building. So I'm showing the results here. So in the left column, which you see, you can see the climate impact of the New Zealand new build detached house, which we expect to be built in the future. So it says around 277 ton CO2 equivalent carbon dioxide for 90-year lifetime building. So at the same time, using this proposed approach, if you calculate the climate target will be around 59 ton CO2 equivalent for the same time period. So that means your climate impacts of the new built detached house should be reduced by around 79%. Similarly, we can do the analysis for the pre-existing detached houses to see what is the reduction required in terms of different, in terms of the building, as well as at different life cycle stages. So to conclude, so these kind of methods will provide an idea about what's the scale of change required to improve the building design, and how to manage the building throughout the operational phase. And also, we are at the moment working on townhouses and apartment to develop similar climate targets, and we have also done the similar work for the commercial office buildings in New Zealand. However, we have to note that these kind of approaches have a large amount of uncertainty, because we use a lot of assumptions and we use a lot of models. For example, the carbon budget, there are different approaches to calculate the carbon budget, and we assign a share of the carbon budget to a building level using a different allocation or sharing principles, and they are also having a kind of uncertainty and influence the results of the proposed approach. We are also working on different scenarios, like what should be a climate target for a building in climate zone 1, like in Auckland, or a building in Wellington, or maybe in Christchurch, because they are having different weather patterns and different environmental conditions. And we also simulate different energy mixes to project how the future energy mix of New Zealand will have influence on the climate impacts of these buildings. To sum up, these kind of approaches will surely have impact on the construction sector, because that will bring stakeholders to think how the future activities and what strategies should be prioritized to enhance the environmental impacts of the building sector. And today I presented the approach for the climate change impact category. So just to finally to wrap up, I would like to thank my supervisors on this project, and also the Building Research Association of New Zealand, who made the data available through the Whole Building Whole of Life framework, and for the funding to complete this research. Also, I would like to thank NASA University and the New Zealand Life Cycle Management Center. Thank you.
Thank you, Chanjeev. That's a very thought-provoking piece of data, particularly the revolutionary need to drop our as-built carbon impact of building new houses by up to 80%. There's a lot of questions come out of that. There's an awful lot of information you've gone through in breaking down our national allocation or budget to the as-built, and for that matter, to the domestic housing situation, and then identifying how much that has to reduce. We've just heard recently from a ThinkStep report that the carbon emissions of New Zealand incorporated can be attributed something of the order of 25% to building. So this is a pretty dramatic demand to keep the planet in order. How do you think it's going to translate? You see brands is involved, and I wonder whether this is going to translate into either the building code or something of that sort. Do you know how this dramatic request is going to be translated?
Yep. So brands is in touch with the Green Building Council New Zealand to develop a new rating tool based on this the proposed approach. So that, for example, if you in the future, if you're going to build a detached house, we're going to set a climate target. So this is the maximum amount of climate impacts you can make. So your building design will be evaluated against the climate target. So you have to calculate what is the climate impacts of the proposed design, and this is the climate target. So your building will be evaluated based on this climate target, and the rating will be done accordingly. So yeah, Francis is discussing with the Green Building Council to progress further with this approach.
Good, because it'll need a good bit of power to get right into the industry, as it were. A lot of people in the industry will be quite, if I dare I say it, quite oblivious to the demands. They might see electric cars, they might see students on the streets talking about climate change, but they won't necessarily relate that to building a house. We will have to wait for the authorities, as you say, to develop a rating tool. Then I imagine they're going to have to push it somehow in terms of getting commitment from particularly the big housing groups that are building hundreds of residential houses, or when you get to apartments. Do you see that as being a huge issue? I suppose that's an understatement.
I'm not sure about the discussion with the building construction companies, but of course there's a large interest from the Green Building Council. But when such a rating tool comes into the practice, and when consumers are aware of these kind of rating tools, then they might demand the builders to adhere to these rating tools. That's what I think personally. So the demand should be created from the consumers for the builders to adhere to these strict rating schemes.
If the subject of climate change is heating up, then the discretionary consumer, the one that's building the new house, it won't necessarily be a huge lifestyle house out in the countryside.
You mentioned lifespan of buildings, and I'm wondering how we address the differences in expectations. For example, local government in New Zealand might say that the lifespan of a residential building is 50 years, but in reality, it might be in place for double that length of time.
So in our study, we have assumed the residential buildings lifetime in New Zealand is 90 years, because it's based on the survey done by Johnston from University of Auckland. So they have been doing this survey, and according to their survey, the current lifetime of the building is 90 years. So at the moment, we are focused on 90 years. But as I told you the last slide, so we are running some scenarios. So when we extend the lifetime, and it may reduce the number of buildings that might be constructed in the future. But I have not presented those results. So we have already considered that aspect of increasing the lifetime of the buildings.
The dynamics of the model that you've set up, if let's say cement, or one of the big heavy emitting products that go into houses, make some sort of radical improvement to their own product, will this in some ways flow through the process so that it either helps achieve the target, or it identifies that we've made progress in this? Let's say cement halves its emissions per tonne of cement. Would this flow through as we develop?
Of course, the change of materials will help to stay within the climate target, and as well as we are planning to update this model based on these inputs every year, so that we'll be on track about the changes the trends which happen in the construction sector. Yeah, so of course we are planning to do this for the next few years. So every year we are planning to update the study in the August-September period. That's the plan at the moment.
Is this approach being used elsewhere in the world? Maybe New Zealand's a nice tiny little bubble in the South Pacific and we can measure things a little bit more clearly in terms of cross-border.
So there is a bit of interest in Denmark, where they have set climate targets for 2 types of buildings, but they have not still considered how the trend will look in the future. So they have set a climate target on the current status for 2010, I think. They have taken the building and evaluated, they set a climate target and compare the climate impacts against the target, but they have not focused on the future buildings of the country. But as far as I had some discussion with those guys, they are currently thinking of setting these kind of climate targets and bringing them into policy actions. Yeah, so there is some uptake, but as you said, is not that much. The main issue with the construction sector is the complexity of the construction sector compared to other sectors.
What do you think would be the single most effective change that could be made in the construction of residential housing? What's the single most effective change?
So we ran a set of scenarios, and so at the moment, the energy sources for the houses are around a 45% of energy consumption is from electricity, and there is a significant amount of natural gas and LPG use at the moment. LPG is small amount, but natural gas there is a significant amount. So if we can convert the buildings 100% electricity, supply the energy, so the requirements by electricity, and a further uptake of some solar power also will help. But still we are in the progress of modeling the future electricity scenario so that we can see. But as far as we are sure that operational use phase of the buildings will have a significant change in the climate impacts of the future detached building sector.
What kind of green innovations could be expected to reduce the operational energy use?
So one thing, at the moment, our electricity is 85% renewable, and we are expecting 100% renewables by 2030, according to the Paris Climate Agreement. So that would be a potential solution, as well as EV to housing. So the energy from electrical vehicles input to the grid system also can have some impacts, I think. But it depends on the uptake of electric vehicles in the future as well.
The next steps in terms of apartments and other building types, and in fact, when you talk about the whole of building, whole of life framework that Brands has been developing for some years now, is that going to lead to similar detailed studies in the apartment residential situation, or is that progressing? Do you know?
Yeah, we are working on this apartments and the townhouses at the moment. So we have already finished calculating the climate impacts of those buildings, and at the moment we are projecting the climate impacts during this particular period. And yeah, we'll be expecting to get the results within 1 or 2 months of time. Yeah, and that will be a detailed study like this, and we are going to do the same thing for the commercial office buildings as well.
And the commercial office buildings should have a reasonable amount of force majeure or help from the coalition and similar people who are committed to science-based targets. So you haven't had any dealings with commercial operators that towards this as a contributor to their science-based targets, have you?
Not at the moment, but once the results are ready, we may surely be in touch with companies which are running these commercial buildings.
you could imagine that those businesses who are committed to sustainability sufficiently well to their own buildings as Green Star
Sure.
sustainability, that they would
Yeah.
be using your data perhaps.
Yeah, particularly the service sector related commercial buildings, they will be surely interested on this kind of approach.
They not choose to use the tool would be the ones causing overshoot. How can we deal with the overshoot, the people who are not going to take notice?
I think that should be done by the government, I guess. It should be a national policy which should come with the answer. There is this kind of uptake of carbon tax in the European countries, but still I don't know how far it's effective in New Zealand. I don't think it's much effective in New Zealand.
No.
Yeah.
See the carbon tax. We don't see the carbon tax flowing into our petrol. We don't see the ETS influence of a carbon cost flowing into petrol, cement, aluminium, glass. The building products that are high intensity emitters, there's no visibility of what the cost is that you're actually paying when you used a lot of cement looking for thermal mass. Then there's no measure of how much the carbon emission has cost you in terms of the cement that you've put into the product, that is the house. Do you think visibility of that might be a valuable piece of information for the builders and designers of housing and buildings in general?
I think the cost is not a major issue in New Zealand as far as I am aware, because there are some consumers, they actually want kind of a lavish big houses. So if there is such a demand, an architect would of course design according to their needs. So in that case, the material cost or the carbon cost won't be an issue. But in order to control such personal decisions, there should be a policy which can control such decisions, I think. Yeah. So there should be some approach from the top to bottom, not and as well as some personal interest.
Well, thank you very much, Chanjeev. I appreciate the work that you've been doing, and I think it's very, very valuable in the conversation of New Zealand's targets and New Zealand's responsibilities with respect to climate change. So I thank you very much for this work, and thank you very much for the presentation.